Welcome to Management 3120's Chapter 6 lecture. This lecture will cover managing quality. So we're going to get started. First, we're going to cover our learning objectives. We're going to define quality and total quality management, otherwise known as TQM. We're going to describe the ISO International Quality Standards. We're going to explain Six Sigma. Then we're going to explain how benchmarking is used in total quality management. We're going to explain quality robust products and the Taguchi Concepts. And then we're going to use the 7 tools of total quality management. So high quality is not an exclusive strategy unto itself. On the contrary, the pursuit of high quality can actually support other strategies discussed in Chapter 2 by satisfying customers' needs or making things run more smoothly or cheaply. It is possible to have high quality and low costs at the same time. And the third bullet you see here is something that all quality gurus recognize, and that's a successful quality management system. It must have top management support, and it involves so much more than implementing a tool or memorizing a list of concepts or Deming's 14 points. Now, studies have shown that high quality products are positively correlated with profitability, so the impacts illustrated on this slide in figure 6.1 are really happening. So you have your improved quality. You're going to experience sales gains via improved response, flexible pricing, improved reputation, and you're going to also have reduced costs via increased productivity, lower rework and scrap costs, and lower warranty costs. And that all results in increased profits. So remember, going back to even Chapter 1, productivity can be considered increased if you have lower inputs. Even with the same outputs. So that kind of corresponds with that same concept. And studies have shown that high quality products are positively correlated with profitability, like we said in the last slide. And the flow and activity shown on this slide will go nowhere without top management support and an organization that emphasizes a true culture of quality. So it's all about the organizational culture. Is quality part of the organization's mission? And quality means different things for different people, for different products and services under different circumstances. It all begins with a good understanding of what the customers expect. The operations manager's objective is to build a total quality management system that identifies and satisfies customer needs. Total quality management takes care of the customer. Now, we accept the definition of quality as adopted by the American Society for Quality, the ASQ, which defines quality as the totality of features and characteristics of a product or service that bears on its ability to satisfy stated or implied needs. Now, others, however, believe that definitions of quality fall into several categories. Now, some of the definitions are user-based. They're proposed that quality lies in the eyes of the beholder. Marketing people like this approach, and so do customers. So to them, higher quality means better performance, nicer features, and other sometimes costly improvements. Now, the production managers, quality is manufacturing based. They believe that quality means conforming to the standards and making it right the first time. Yet a third approach is product based, which views quality as a precise and measurable variable. In this view, for example, really good ice cream has high butterfat levels. And this slide is particularly important. High quality does so much more than just reduce rework costs. The reputation and implications can have a huge impact on profitability, and it is so difficult to recover from bad publicity about quality. Essentially, you have to go into rebranding efforts. It's pretty significant. Can do a lot of damage to an organization. Furthermore, several firms over the past years have gone bankrupt due to liability stemming from product defects. Company reputation. An organization can expect its reputation for quality, be it good or bad, to follow it. Quality will show up in perceptions about firms' new products, employment practices, and supplier relations. Self-promotion is not a substitute for quality products. Product liability. The courts increasingly hold organizations that design products or distribute faulty products or services liable for damages or injuries resulting from their use. So legislation such as the Consumer Product Safety Act sets and enforces product standards by banning products that do not reach those standards. Impure foods that cause illnesses, nightgowns that burn, tires that fall apart, or auto fuel tanks that explode on impact can be huge legal expenses. It can result in large settlements or losses and terrible publicity. Now you have the global implications. And this technological age, quality is an international as well as operations management concern. So for both a company and a country to compete effectively in the global economy, products must meet global quality design and price expectations. Inferior products harm a firm's profitability and a nation's balance of payments. Now, the global implications of quality are so important that the U.S. has established the Malcolm Baldrige National Quality Award for quality achievement. The award is named for former Secretary of Commerce Malcolm Baldrige. Winners include such firms such as Motorola, Xerox, FedEx, Ritz-Carlton Hotels, AT&T, Cadillac, and Texas Instrument. You're going to hear a little bit more about Motorola because it certainly was very pioneering and engaged in a lot of benchmark approaches to quality, as you'll see when we cover Six Sigma. Now, the move towards global supply chains has placed so much emphasis on quality that the world has united around a single quality standard. That is the ISO 9000. ISO 9000 is the quality standard with international recognition. Its focus is to enhance success through 8 quality management principles. So the ISO standard encourages establishment of quality management procedures, detailed documentation, work instructions, and record keeping. Like the Baldrige Awards, the assessment includes self-appraisal and problem identification. Now, unlike the Baldrige, ISO certified organizations must be re-audited every 3 years. So it's really a true validation of an organization that fosters high quality standards. Now, the latest modification of the ISO 9000 is the ISO 9001. 2015 follows a structure that makes it more compatible with other management systems. This version gives greater emphasis to risk-based thinking, attempting to prevent undesirable outcomes, and over 1 million certifications have been awarded to firms in 206 countries, including approximately 30,000 in the United States to do business globally. And it is critical for a firm to be certified and listed in the ISO directory. Now, the ISO 9000 focus is to enhance success through 8 quality management principles. First, you have top management leadership. Second, customer satisfaction. Third, continual improvement. Fourth is the involvement of people. Fifth is process analysis. And 6, use of data-driven decision-making. And 7, a systems approach to management. And 8, mutually beneficial supplier relationships. There are 4 major categories of costs that are associated with quality, which are as follows. These are the prevention costs, and those costs associated with reducing the potential for defective parts or services. This would be your training programs or quality improvement programs. They're all your prevention methods. You have your appraisal costs, and those are costs related to evaluating products, processes, parts, and services. And these are your testing labs and inspectors. Next, we have your internal failure costs, and these are your costs that result from production of defective parts or services. It's before delivery to the customer. So you have your rework costs, your scrap costs, costs from downtime, and then you have your external failure costs, and these are the costs that occur after delivery of the defective parts or services. And this is again, your rework, your return goods, your liabilities that we talked about earlier, lost goodwill, and cost to society. The first 3 costs, being prevention, appraisal, and internal, can be reasonably estimated, but the external costs are very, very hard to quantify. And here's where the concept of making it right the first time can be emphasized. Spending more on prevention usually leads to bigger savings in failure costs and potentially even appraisal costs. Now, in particular, external failure costs may exceed the price of the final product itself, which you don't want, and that can be devastating in terms of company reputation. So it all falls back to the old carpenter's quote. It's very applicable here, and that's measure twice and cut once. So these slides describe some of the pioneers of quality management. Deming was probably the most influential here. In fact, the Japanese honor Deming by naming their nationally quality prices after him. An interesting film about Deming was produced that shows him in action later in life, and both he and Duran were not particularly charismatic. Edward W. Edwards Deming, he insisted on the data management, except the responsibility for building good systems. The employee cannot produce products that on average exceed the quality of what the process is capable of producing. And his 14 points for implementing quality improvement are presented later in this chapter. We're going to cover them here momentarily. You have Joseph N. Duran, a pioneer in teaching the Japanese how to improve quality. Duran believed strongly in top management commitment, support, and involvement in the quality effort. He was also a believer in teams that continually seek to raise quality standards. And Duran varies from Deming somewhat on focusing on the customer and defining quality as fitness for use, not necessarily the written specifications. So Crosby, on the other hand, he displayed charisma like an infomercial professional, in a general and a positive way. So Crosby definitely focused less on quantitative aspects of TQM or total quality management than the other pioneers did. So an important way that Duran differed was the idea of choosing the balance, actually choosing a different defect level, which would be less than 1%. that minimize the cost of quality. Finding the balance between prevention and failure costs. So Deming and Crosby, on the other hand, preach about striving for and attaining zero effects. So, Crosby's one of the most, I guess, noted people you'll cover here as far as the pioneers. And he's noted for the quote, quality is free. And that's the attention-getting book that was published in 1979. He believed that in the traditional trade-off between the cost of improving quality and the cost of poor quality, the cost of poor quality is understated. The cost of poor quality should include all the things that are involved in not doing the job right the first time. And Crosby coined the term zero defects and stated there's absolutely no reason for having errors or defects in any product or service. The point about responding to problems is particularly important. Mistakes happen, but how does an ethical company respond and make it right? Now, for operations managers, one of the most important jobs is to deliver healthy, safe, and quality products and services to customers. The development of poor quality products because of inadequate design and production processes not only results in higher production costs, but also leads to injuries, lawsuits, and increased government regulation. If a firm believes that it has introduced a questionable product, ethical conduct must dictate the responsible action. Now, this may be a worldwide recall, which we're familiar with, as conducted by both, Johnson & Johnson did it for Tylenol, and Perrier did it for its spring water when each of these products was found to be contaminated. A manufacturer must accept the responsibility for any poor quality product released to the public. There are many stakeholders involved in the production and marketing of poor quality products, including stakeholders, employees, customers, suppliers, distributors, and creditors, just to name a few. As a matter of ethics management, must ask if any of these stakeholders are being wronged, and every company needs to develop core values that become day-to-day guidelines for everyone from the CEO down to the production line employees. And total quality management, that refers to a quality emphasis that encompasses the entire organization from the supplier to the customer. And TQM stresses a commitment by management to have continuing company-wide drive towards excellence in all aspects of products and services that are important to the customer. Now, each of the 10 decisions that we have covered in previous chapters, which are made by operations managers, deal with some aspects of identifying and meeting customers' expectations. Now, meeting those expectations requires an emphasis on total quality management / TQM, if a firm is to compete as a leader in the world markets. Now we're back to W. Edwards Deming, quality expert here. He used 14 points to indicate how he implemented total quality management. And 7 of them were listed right here on this slide. So he created a consistency of purpose. He led fostered leading to promote change, build quality into the product, stop depending on inspections to catch problems, build long-term relationships based on performance instead of awarding business on price, and continuously improve product quality and service, start training, and always emphasize leadership. And the remaining 7 on this slide, Deming's points represent one framework to think about when implementing TQM. So you drive out fear, break down barriers between departments, stop haranguing workers. Support, help, and improve, the organization, your employees. Remove barriers to pride in work. Institute a vigorous program of education and self-improvement, and put everyone in the company to work on the transformation. Remember, everybody's a change agent in some way or another. So the textbook here developed the aforementioned 14 points into 7 concepts for an effective TQM program. Now, your first one is going to be continuous improvement. Second is Six Sigma. Your third is employee empowerment. 4 is benchmarking. 5 is just in time, otherwise known as JIT. The Taguchi Concepts, and 7, knowledge of TQM tools, those tools. Now, continuous improvement is like a race with no finish line. The runner can celebrate and take a break now and then, but then he or she needs to get back on that road and keep going further. So look at total quality management. It requires a never-ending process of continuous improvement that covers people, equipment, suppliers, material, and procedures. The basis of the philosophy is that every aspect of an operation can be improved, and the end goal is perfection, which is never achieved, but it's always sought. And we're going to talk about plan, do, and check, act. Okay, that's the PDCA approach. That's your acronym to know. The PDCA, it stands for plan, do, check, and act. So Walter Shewhart, another pioneer in quality management, developed a circular model known as the PDCA, as depicted here, as his version of continuous improvement. So, Deming later took this concept to Japan during his work there after World War II. And the PDA cycle, also known as the Deming circle or the Shewhart circle, is shown here in figure 6.3. as a circle to stress the continuous nature of improvement processes. So I want to go over the circle here. So you have your step 1, and there's your P, your plan. And that's where you're going to identify the problem and make a plan. Next, you have your D, and that's your do, and you're going to test the plan. Next, you're going to check, that's your C, and that is you're checking to see if the plan is working. And then 4, you're going to act. That's your A, and that's implement the plan or document. You want to document how the plan's going. Now, the Japanese use the word kaizen to describe this ongoing process of unending improvement. The setting and achieving of even ever higher goals. In the U.S., TQM and zero defects are also used to describe continuous improvement efforts. But whether it's PDCA, Kaizen, TQM, or zero defects, the operations manager is a key player in building a work culture that endorses continuous improvement. In some ways, Six Sigma is a modern rewording of old TQM concepts. TQM's been around a while. It's definitely been modernized. But Six Sigma certification program, being black belts and green belts, that has become highly valued for those that attain the certification. In some ways, it is quality management's equivalent to a CPA in accounting or the CFA in finance. And a nice feature of the certification is that it involves not only passing an exam, but also real-world experience in managing quality improvement projects. Yeah, you need your hours, documented hours. The term Six Sigma was popularized by organizations such as Motorola, Honeywell, and General Electric, and it has 2 meanings in total quality management. So in a statistical sense, is describes a process, product, or service with an extremely high capability. So we're talking about an accuracy of 99.9997% accurate. And the second TQM definition of Six Sigma is a program designed to reduce defects to help lower costs, save time, and improve customer satisfaction. Six Sigma is a comprehensive system, a strategy, a discipline, and a set of tools for achieving and sustaining business success. And this slide, figure 6.4, specifically depicts the statistical sense of Six Sigma. In this example, if 1 million passengers pass through the St. Louis airport with checked baggage each month, a Six Sigma program for baggage handlers will result in only 3.4 passengers with misplaced luggage. Okay, so you see that all the way over there to the left. Now, and then you have the more common 3 Sigma program would result in 2,700 passengers with misplaced bags every month. Now, Motorola developed Six Sigma in the 1980s in response to customer complaints about its products and in response to stiff competition. The company first set a goal of reducing defects by 90%. And within 1 year, it had achieved such impressive results through benchmarking competitors, soliciting new ideas from employees, changing reward plans, adding training, and revamping critical processes, that it documented the procedures into what is called now as Six Sigma. Although the concept was rooted in manufacturing, GE later expanded Six Sigma into services, including human resources, sales, customer service, and financial credit services. The concept of wiping out defects turns out to be the same in both manufacturing and services. Now you got to remember, Six Sigma is a strategy because it focuses on total customer satisfaction. It is a discipline because it follows the normal Six Sigma improvement model known as the DMAIC. This 5-step process improvement model encompasses, the first one is it defines the project's purpose, scope, and outputs, and then identifies the required process information, keeping in mind the customer's definition of quality. So that's your D, it defines. Your M is that it measures. And what does it measure? It measures the process and collects the data. Then you have your A, and that's for analyzes. It analyzes the data, ensuring repeatability, and that's the results that can be duplicated, and the reproducibility, and that's others get the same results. And then your number 4 is the I. It improves by modifying or redesigning existing processes and procedures. And number 5, the C, it controls the new process to make sure performance levels are maintained. Six Sigma is a set of 7 tools that we should be touching on later in this lecture, involving check sheets, scatter diagrams, cause and effect diagrams, Pareto charts, flow charts, histograms, and statistical process control. And here we have the DMAIC model again. I just went over it, but I'm going to go over it again for you. So there's your D. It defines the project's purpose, scope, and outputs. Then identifies the required process information, keeping in mind the customer's definition of quality. Your M is that measures. What does it measure? It measures the process and collects data. Your A is analyzes the data, ensuring repeatability and reproducibility. Your I is that it improves. And what does it improve? It improves by modifying or redesigning existing processes and procedures. And then C, it controls. and it controls the new process to make sure performance levels are maintained. So implementing Six Sigma is a big commitment. Indeed, successful Six Sigma programs in every firm, and it's stemming from GE to Motorola to DuPont to Texas Instruments, require a major time commitment, especially from top management. These leaders have to formulate the plan, communicate their buy-in and the firm's objectives, and then take a visible role in setting the example for others. Now, successful Six Sigma projects are clearly related to the strategic direction of a company, and it is a management-directed, team-based, and expert-led approach. So remember, it emphasized effects per million opportunities as a standard metric, provides extensive training, focuses on top management leadership, that's the champion it, create qualified process improvement experts, being your black belts and green belts, and you're going to set stretch objectives. Now remember, this cannot be accomplished without a major commitment from top level management. It has to come from the top. Now, arguably, employee empowerment represents the most powerful means to improving quality in an organization. Often people closest to the actual work know best how to improve it. A key feature for success is to properly reward employees for helping to improve the quality. And employee empowerment means involving employees in every step of the production process. Consistently, research suggests that some 85% of the quality problems have to do with materials and processes and not with employee performance. Therefore, the task is to design equipment and processes that produce the desired quality. And this is done with a high degree of involvement by those who understand the shortcomings of the system. Now, those dealing with the system on a daily basis they understand it better than anyone else. One study indicated that TQM programs that delegate responsibility for quality to shop floor employees tend to be twice as likely to succeed as those implemented with top-down directives. Now, when non-conformance occurs, the worker is seldom at fault. Either the product was designed wrong, the process that makes the product was designed wrong, or the employee wasn't properly trained. Now, although the employee may be able to help solve the problem, the employee rarely causes it. So techniques for building an employee empowerment program include, first building communication networks, and that has to include the employees. Two, developing open, supportive supervisors. Three, moving responsibility from both managers and staff to production employees. 4, building high morale organizations. And 5, creating such formal organization structure as teams and quality circles, which leads us to discuss quality circles a little more. So teams can be built to address a variety of issues. Once popular focus of teams is quality. Such teams are known as quality circles. And here we have a quality circle is a group of employees who meets regularly to solve work-related problems. And the members receive training in group planning, problem solving, and statistical quality control. They generally meet once a week, usually after work, but sometimes on company time. And although the members are not rewarded financially, they do receive recognition from the firm. And a specially trained team member called the facilitator usually helps train the members and keeps the meetings running smoothly. Teams with a quality focus have proven to be a cost-effective way to increase productivity as well as quality. Benchmarking is another ingredient in an organization's TQM program. Now, benchmarking involves selecting a demonstrated standard of products, services, costs, or practices that represent the very best performance for processes or activities very similar to your own. Now, the idea is to develop a target at which to shoot and then to develop a standard or benchmark against which to compare your performance. And the steps for developing benchmarks are: first, to determine what to benchmark. Next, form a benchmark team. The third is to identify benchmarking partners. 4 is to collect and analyze benchmarking information. And 5 is to take action to match or exceed the benchmark. Now, note that benchmarking does not have to examine only firms in the industry. Examining world-class organizations from other industries can lead to some great ideas, and those companies might be more willing to share the information. And benchmarks often take the form of best practices found in other firms or in other divisions. Table 6.3 on this slide illustrates best practices for resolving customers' complaints. So the best practice, make it easy for clients to complain, respond quickly to complaints, resolve complaints on first contact, and use computers to manage complaints, and recruit the best for customer service. Now, internal benchmarking can be more effective than external benchmarking when the organization is large enough to have multiple divisions or business units. The philosophy behind just-in-time, or JIT, is one of continuing improvement and enforced problem solving. Just-in-time systems are designed to produce or deliver goods just as they are needed, and just-in-time is related to quality in 3 ways. You have to pull a system of production scheduling, including supply management. Production only when signaled. Allows you to reduce inventory levels and inventory costs, money, and hides processes and material problems, and encourage improved process and product quality. So, just in time, cuts the cost of quality. Now, this occurs because scrap, network, inventory investment, and damage costs are directly related to inventory on hand. Now, because there is less inventory on hand with JIT, just in time, costs are lower. And in addition, inventory hides bad quality, whereas JIT immediately exposes bad quality. And just-in-time improves quality as just-in-time shrinks lead time. It keeps evidence of errors fresh and limits the number of potential sources of error. So just-in-time creates, in effect, an early warning system for quality problems both within the firm and with vendors. And better quality means less inventory and a better / easier to employ JIT system. Often the purpose of keeping inventory is to protect against poor production performance resulting from unreliable quality. If consistent quality exists, just-in-time allows firms to reduce all the costs associated with the inventory. Taguchi created systematic methods to design experiments that identify the variables affecting product variation, and these are fractional factorial experiments. He also has provided us with 3 important concepts identified on this slide. Quality robustness refers to products that are consistently built to meet customer needs despite adverse conditions in the production process. And target-oriented quality refers to a philosophy of continuous improvement to bring a product exactly on target. Then you have the quality loss function, the QLF. And that refers to a mathematical function that identifies all costs connected with poor quality and shows how these costs increase as output moves away from the target value. And this slide focuses on quality robustness, wherein products whose quality is not hampered by variation in conditions. Remember, the ability to produce products uniformly in adverse manufacturing and environmental conditions, and that's you remove the effects of adverse conditions, and then small variations in materials and process do not destroy the product quality. Now, Taguchi suggests that focusing on removing the effects of variations can often be cheaper than attempting to eliminate the causes. So remember that target-oriented quality, it shows that costs increase as the product moves away from what the customer wants. Costs include customer dissatisfaction, warranty, and service, internal scrap and repair, and costs to society. And traditional conformance specifications are too simplistic. Now, a study found that U.S. consumers preferred Sony's TVs made in Japan over the Sony TVs made in the United States, even though the factories used the exact same designs and specifications. And the difference in approaches to quality generated the difference in consumer preferences. So, in particular, the U.S. factory was conformance-oriented, accepting all components that were produced within specification limits. On the other hand, the Japanese factory strove to produce as many components as close to the actual target as possible, as depicted here on this slide. Much more of the Japanese output centered around the target, or the center of the upper and lower limits. Clearly, this target-oriented approach led to higher quality final products. Why? Now, imagine many slightly large bolts fitting into slightly small nuts, and that's the connections that are too tight. And other slightly small bolts fitting into slightly large nuts, connections that are too loose. Add all those up over many components in a TV, and more things will go wrong. So you're starting to get deviate from the quality standard. Taguchi aims for the target because the products produced near the upper and lower acceptable specifications result in a higher quality loss. Now, to empower employees and implement TQM as a continuing effort, everyone in the organization must be trained in the techniques of TQM. In this slide, we'll focus on some of the diverse and expanding tools that are used in the TQM crusade. So you have the check sheet, you have the scattered diagram, you have the cause and effect diagram. Tools to organize the data involve the Pareto chart, also the flow chart, otherwise known as the process diagram. And this slide begins the list of the tools for identifying problems, being the histogram and the statistical process control chart. Now, check sheets. A check sheet is any kind of a form that is designed for recording data. In many cases, the recording is done so the patterns are easily seen while the data are being taken. And check sheets help analysts find the facts or patterns that may aid subsequent analysis. So an example might be a drawing that shows a tally of the areas where defects are occurring, or a check sheet showing the type of customer complaints. And scatter diagrams. Scatter diagrams show the relationship between two measurements. An example is a positive relationship between length of a service call and the number of trips a repair person makes back and forth with the truck for parts. And another example might be a plot of productivity and absenteeism, as shown here in figure 6.6b. If the two items are closely related, the data points will form a tight band. And if a random pattern results, the items are unrelated. Then you have your cause and effect diagrams, and that's another tool for identifying quality issues and inspection points. Is the the cause and effect diagram, aka fishbone diagram. Figure 6.7 here illustrates a chart. Note the shape resembling the bones of a fish for a basketball quality control problem. And we're going to get to that right here. Okay, so figure 6.7 has problems caused by hand position, follow through, aiming point, bent knees, and balance. So when a fishbone chart is systematically developed, possible quality problems and inspection problems are highlighted. Back to 6.6 here. Now remember, the operations manager starts with 4 categories: material, machinery or equipment, manpower, and methods. So the material, machinery, manpower, and methods, those are known as the 4 M's, and they're the causes. And they provide a good checklist for the initial analysis. So individual causes associated with each categories are tied in as a separate bone along that branch, other through brainstorming processes. And Pareto charts are a method of organizing errors, problems, or defects to help focus on problem-solving efforts. They are based on the work of Vilfredo Pareto, a 19th century economist. Joseph Duran popularized the Pareto's work when he suggested that 80% of a firm's problems are the result of 20% of the causes. So only 20% of the causes result in 80% of the firm's problems. Now, flowcharts graphically present a process or system using annotated boxes and interconnected lines. They are simple, but a great tool for trying to make sense of a process or explain a process. And histograms show the range of values of a measurement and the frequency with which each value occurs, as depicted here in figure 6.6F. They show most frequently occurring readings as well as the variations in the measurements. Descriptive statistics such as the average and the standard deviation may be calculated to describe the distribution. However, the data should always be plotted so the shape of the distribution can be seen. A visual presentation of the distribution may also provide insight into the cause of the variation. And the statistical process control monitors standards and makes measurements and takes corrective action as a product or service is being produced. Uses statistics and control charts to tell when to take corrective action. It drives process improvement. And there's 4 key steps. First, you're going to measure the process. When a change is indicated, you're going to find the assignable cause. And then you're going to eliminate or incorporate the cause, and then you're going to restart the revised process. Samples of processes outputs are examined if they are within acceptable limits. The process is permitted to continue, and if they fall outside certain specific ranges, the process is stopped and typically the assignable cause located and removed. And here in figure 6.6G is your statistical controls chart, a chart with time on the horizontal axis to plot values of a statistic. Now, control charts are graphic presentations of data over time that show upper and lower limits for the process we want to control, as depicted here in figure 6.6G. In the old days, the only form of quality management implemented by companies was the inspection activity. So to make sure a system is producing as expected, control of the process is needed. The best processes have little variation from the standard expected. So in fact, if a variation were eliminated, there would be no need for inspection because there would be no defects. The operations manager's challenge is to build such systems. However, inspection must often be performed to ensure that processes are performed to standard, and this inspection can involve measurement, tasting, touching, weighing, or testing of the product, sometimes even destroying it when doing so. Its goal is to detect a bad process immediately, and inspection does not correct deficiencies in the system or defects in the products, nor does it change product or increase its value. Inspection only finds deficiencies and defects. Moreover, inspections are expensive and do not add value to the product. Inspection should be thought of as a vehicle for improving the system, and operations managers need to know critical points in the system. 1, when to inspect, and 2, where to inspect. Deciding when and where to inspect depends on the type of process and the value added at each stage. So inspections can only take place at any of the following points. First, at your supplier's plant while the supplier is producing. Second, at your facility upon receipt of the goods from your supplier. Third, before costly or irreversible processes. 4, during the step-by-step production process. 5, when production on service is complete. 6, before delivery to your customer. And 7, at the point of customer contact. Ideally, suppliers are delivering perfect materials and products that are made right the first time, which would minimize the need for a lot of inspections. What drives inspections? You have many problems, starting with worker fatigue, measurement errors, process variability. You cannot inspect quality into a product. Robust design, empower employees, and sound process are always better solutions. Source inspection is the concept of controlling or monitoring at the point of production or purchase, and this is consistent with the idea of employee empowerment, where employees self-check their own work. And this slide describes useful tools for source inspection. Poka-yoke, foolproof devices or techniques, and checklists, which are surprisingly effective. If done correctly, source inspection would eliminate the need for extra inspections anywhere else. Poka-yoke is defined as mistake proofing. It has come to mean a device or technique that ensures the production of a good unit every time. And a checklist is a type of poka-yoke that lists the steps needed to ensure consistency and completeness in a task. In service-oriented organizations, inspection points can be assigned at a wide range of locations as illustrated here in Table 6.4. And again, the operations manager must decide where inspections are justified and may find the 7 tools of total quality management useful when making these judgments. I want to go back to this one. Here you have Alaska Airlines. We're going to touch on them here in a little bit. And what is inspected, you have your last bag on the carousel, airplane door open, and over to the right are the standards. Last bag on the carousel, less than 20 minutes after arrival at the gate. So there's your measurable standard. Airplane door open, less than 2 minutes after arrival at the gate. That's a measurable standard. And as you can see, inspection can be important in services as well as in manufacturing. And here's another example. So when inspections take place, quality characteristics may be measured as either attributes or variables. Attribute inspection classifies items as being either good or defective. It does not address the degree of failure. For example, the light bulb burns or doesn't. Variable inspection measures such dimensions as weight, speed, size, or strength to see if an item falls within an acceptable range. And if a piece of electrical wire is supposed to be 0.01 inches in diameter, a micrometer can be used to see if the product is close enough to pass the inspection. Knowing whether attributes or variables are being inspected helps us decide which statistical control approach to take. Now, the personal component of services is more difficult to measure than the quality of the tangible component. Now, generally, the user of a service, like the user of a good, has features in mind that form a basis for comparison among alternatives. Lack of any one feature may eliminate the service from further consideration. And quality also may be perceived as a bundle of attributes in which lesser characteristics are superior to those the competitors. And this approach to a product comparison differs a little between goods and services. However, what is very different about the selection of services is the poor definition of 1, tangible differences between products, and 2, the tangible expectations customers have on those products. Indeed, the intangible attributes may not be defined at all, and they are often unspoken images in the purchaser's mind, and this is why all of those marketing issues such as advertising, image, and promotion can make a difference. So the operations manager plays a significant role in advertising several major aspects of service quality. First, the tangible component of many services is important. That's how well the service is designed and produced. Does it make a difference? This might be how accurate, clear, and complete your checkout bill is at the hotel, how warm the food is at Taco Bell, or how well your care runs after you pick it up, your car runs after you pick it up at the repair shop. Second, another aspect of service and service quality is the process. Determinants of service quality include reliability, responsiveness, competence, access and approachability, courtesy, communication, credibility, security, understanding and knowing the customer, and tangibles or physical evidence of the service. And you have number 3, and that's the operations manager should realize that the customer's expectations are the standard against which service is judged. Customers' perceptions of service quality result from a comparison of their before service expectations with their actual service experience. In other words, service quality is judged based on the basis of whether it meets expectations. The manager may be able to influence both the quality of the service and the expectation. So don't promise more than you can deliver. And number 4 here, we have the manager must expect exceptions. There is a standard quality level at which regular service is delivered, such as a bank teller's handling of a transaction. However, there are exceptions or problems initiated by the customer or by less than optimal operating conditions, such as computer crashing. This implies that the quality control system must recognize and have a set of alternative plans for less than optimal operating conditions. Like many service organizations, Alaska Airlines sets quality standards in areas such as courtesy, appearance, and time. Shown here are some of Alaska Airlines' 50 quality checkpoints based on a timeline for each departure. And they're right there along the bottom and the top, you see. Now we're going to revisit those determinants of service quality a little more in depth. So remember, we have reliability, and that involves the consistency of performance and dependability. We have responsiveness, and that concerns the willingness or readiness of employees to provide service. Then you have competence, and that means possession of the required skills and knowledge to perform the service. You have access, and that involves approachability and ease of contact. And then you have courtesy, and that involves politeness, respect, consideration, and friendliness. And continuing with the determinants of service quality, we have communication, and that means keeping the customers informed and listening to them. We have credibility, that involves trustworthiness, believability, and honesty. Then we have security, and that is the freedom from danger, risk, or doubt. And then you have understanding or knowing the customer, and that involves making the effort to understand the customer's needs. And the tangibles include the physical evidence of the service. So, well-run companies have service recovery strategies. And this means they train and empower frontline employees to immediately solve problems. For instance, the staff at Marriott Hotels drilled the LEARN routine. That's an acronym, LEARN, L-E-A-R-N. That is to listen, empathize, apologize, react, and notify, with the final step ensuring the complaint is fed back into the system. And managers of service firms may find that ServQual, that's another acronym, SERVQUAL, they find it useful when evaluating performance. ServQual is a widely used instrument that provides direct comparisons between the actual between the service and what is actually provided. ServQual focuses on the gaps between customer service expectations and the service provided on 10 service quality determinants, and designing the product, managing the service product, and matching the customer expectations to the product, and preparing for the exceptions as keys to quality services. And this concludes the Chapter 6 lecture. Please check on the expectations and the deliverables for this chapter, and I will see you in Chapter 7.